So, yesterday, we were rearranging some formulas. What else did we do yesterday? We were looking at how I want you to substitute things. We were looking at fire drill. Love me some fire drill. We looked at rearranging formulas. I did 3 or 4. I wanted you to try 4. Some of them are trivially easy, and some of them are a little more involved, shall we say. I'll go over the answers to these 5, make sure we're comfortable with them. I will do a little bit of the relationships between variables and show you how to analyze some of those. But the large portion of today is going to be for you guys to work through some more practice on this stuff with some support if you need it. Then tomorrow we'll look at trig. You know what? If you work through all the stuff fast today, maybe we end today with some trig. We'll see. Here we go. So, for number 5, you're isolating that thing. Am I recording? Yes, I'm recording. You're isolating that expression there for P. I saw a few yesterday. I can go through it if you'd like. But one of the expressions that I saw for question 5 would have looked like this. P equals negative 1/3, and then in brackets, MF minus 7D minus 8X. I also saw MF minus 7D minus 8X all over -3. Those are, to my reckoning, the only 2 acceptable. I mean, you could go a little bit ridiculous and put that fraction, that -3, under every single term individually. That's an option too, I suppose. Did anyone do something different or want me to demonstrate how this would be done? Ramesh, did I call you? No, I did not. How did I skip you? I have clearly not forgotten you. Where are you on my list, Ramesh? Does that mean I forgot some other people too? No, I went straight from Bruce to Seneca. Ramesh, you can live anywhere in the world. Where are you going to live? Tokyo it is. Did I skip anybody else? Okay, I didn't think I did. Okay. You have a different answer?
Just like fixed up the negative positives.
Oh, you have a different answer to my attendance question or a different answer to this one? Okay, let's do it. So I'll demonstrate for you how I would have gone through this in green over here on the side. So if you have MF equals 7D minus 3P plus 8X. Abdu, what was your first step? I mean, that's the goal. That's the final step. What did you do along the way? Okay. You took away 8X and you took away 7D. So you got MF minus 7D minus 8X. I'm willing to bet your mistake here was that you said this was equal to 3P. Oh, so you did have equal negative 3P.
And I multiplied everything on the first side equal by -1.
So you went negative, positive, positive, positive.
Yes.
Yes. Okay, sorry. That is a third, yes, totally acceptable way to write this answer. You could also have written it like this. Equals 1/3 negative MF plus 7D plus 8X. Yes, that's fine too. You could have brought on this one, brought the negative inside. So it's negative MF plus 7D plus 8X all over 3. Yes, Abdu, that is acceptable as well. Yes. Okay, 6, you're solving for D6 is trivially easy. It's interesting that it got thrown down here. You're dividing by something, you want to get rid of the thing that you're dividing by, so we multiply both sides by T. And you're going to have D equals, I like to write it as VT for reasons that will make sense in a couple days. Or T times V, ultimately it doesn't matter. Number 7. There are a number of acceptable answers, if I'm not mistaken, to 7. The one that I like the best looks like this. You're solving for A. So A is going to equal D minus VIT. In brackets, you could write it like this. You could have your half T squared in the denominator. That's totally acceptable. You could have multiplied it by 2 instead of dividing by the half and written it like this. VIT over T squared. Or if you wanted to, you could distribute that 2 in and get something looks like this. 2d minus 2vit all over t squared. Did anyone do anything different? There are other ways, there are further ways to simplify some of that. Sienna?
Put the exponent, like the t to the 2, and that's the square root.
Because you're not isolating for it, you wouldn't root anything.
Okay.
There's no exponent on the a, so there's no reason to square root anything.
Okay, yeah, that makes more sense.
Yeah.
If you multiply by going to the side, remove the
Yeah, you should get something that looks like one of these two then. You'll get the 2d minus 2vit. So what you're saying is, did you multiply by 2 right away to get rid of the half? So then you need to make sure you multiply the d and the vit by 2. Every term needs to get multiplied by 2 to get rid of that half. So if you didn't get something that looks like this, then you didn't multiply this term by the 2 as well. Got to be careful when you're doing that. Anybody else? Question number 7. Okay. Then number 8, you're isolating number 8 for VF, which is this guy right here. There are a couple. Do I have a couple? How many solutions do I have to this one? Yeah, I've got 2 that look like this. VF is either going to be 2d minus vi. Ooh, how did I do this? VIT all over t. That's one totally acceptable possible answer. The other one that I got looked like this. VF is going to be equal to 2d over t, just alone, minus vi. Did anyone get something different or want me to go through how I did that? Andrew, what'd you get?
VF equals, in parentheses, VI over 2 times t minus, in parentheses again.
Wait, were brackets inside brackets?
Yeah, brackets.
I want to make sure I'm writing down what you're saying properly. Is it like closed like this?
No, the t is
The t is where?
on the outside of the brackets.
So you want a bracket between the vi over 2 and the t?
Yeah. Wait.
You know what, Andrew?
Over 2 is in brackets.
Vi over 2 is in brackets.
Yes.
Okay.
But not implied, it's not written, but times t.
T.
Right. Minus, then all of this is in brackets, d divided by t.
Okay, there is a mistake there.
Okay.
Because it looks a little bit like this one. Okay, so walk me through how you got to that point. Now let's see if we can figure out where...
Oh, I have no clue.
Oh, you didn't show your work? You did it all in your head and got... classic. You did it all in your head, got it wrong, and now I can't help you. Cool. So your answer, I will most assuredly tell you, is incorrect.
All right.
Because... Well, for a few reasons, actually. Or is my work incorrect? I don't think my work's incorrect. No, that's that one. But if you substitute or cancel that, you got that one there. Yeah, Andrea, I can only tell you that your answer is not correct. But because you have no work shown and you don't, this is exactly what I was trying to tell you several days ago. You don't remember how you did it.
Oh, no, I did this like 2 minutes ago.
Oh, okay. You still don't remember. Whenever you did it, you still don't remember how you did it. I can't help you determine why it's wrong. I just know that it is. Abdu.
I got the same answer you got, but the 2 is outside of the thing. Like the d over t is in, no, the second one, yeah. D over t is in brackets and 2 is outside.
It doesn't change. That is not
Same thing, right?
not a different result. It's the same. It's exactly the same. I just wouldn't put. Yeah, when you have. So yours look like that.
Yeah.
Same thing. Yeah, absolutely the same thing. Cool. There are no questions on these 4. There are times when students are sitting here, especially in this section, you're freaking out about the algebra. This first chapter will be the grossest algebra that I give you. It only gets easier from this algebra. So if you're freaking out here now about your math skills will be most firmly tested in chapter 1, and it will be kinder for all the subsequent chapters. Okay, flip the page. Here we go. Let's look at relationships between variables. This is a kind of an abstract, somewhat of an abstract exercise that happens in physics all the time. Not really, it doesn't really get dealt with anywhere else, because we do deal with abstracts fairly regularly in physics. And it says things, so the question will say things like this. We have a formula, F equals ma. So this is a relatively small formula. The second formula is F equals gmm over d squared. This is related to gravity. This is related to Newton's second law. We'll get there. But two formulas that we use in physics. And it says, okay, given that these formulas exist, and if all other variables remain unchanged, what happens? How do we interpret what happens if, or to F if A doubles? Or what happens to F if the mass is decreased by a third? Or if what happens to the mass if A halves? And we can think about how do the relationships in these variables change? And it's very much a mental exercise because we're not actually working with values here. So I'll show you what I mean. What happens to F if A doubles? So the expression is F equals ma. That's where we're starting, and we're saying, okay, I'm going to double A. Well, the act of doubling A just means multiplying it by 2. So I'm just going to substitute A into this expression, and I'm going to say that F is equal to, or I'll call this F1, is going to be equal to M times 2A. And then what the question is asking you to determine is how does this relate to the original expression for F? Well, and for this one, this new F, I've got M times 2A, and I can just rearrange this. I can multiply things in whatever order I want, so I can rewrite this as F1 is going to be equal to 2 times M times A. But what is this? What's MA? Well, if you look back, we said the way we originally defined the question was that our original value for F is equal to M times A. So I'm going to take this and I'm actually going to substitute it in here. The math isn't difficult, but it's an interesting mental exercise. What we're going to get is that then this F1 is going to be equal to 2 times our original F. So then the answer to the question that we're being asked, what happens to F if I double A? Well, F gets twice as big. Does that make sense? Kind of the reasoning behind what I did here. Comments, questions, concerns about what I just did? Jedediah. Nope. Would it help to see do another one? Let's do another one. Okay, same idea. So I want to analyze F again. What happens to, and maybe it'll help if I actually use the proper language for these variables. F stands for the force on something. M stands for the mass of the object. And A is the acceleration of that object. So what this relationship is saying, and we'll go over it in chapter 3, what this relationship is saying is that if you're going to apply a force to an object, the force that you're applying to the object is going to be equal to the mass of the object times the acceleration of the object. Because if you apply a force to something, generally speaking, it accelerates. A net force to something, it accelerates. If I push you, you will move. Unless I don't push you hard enough. And so what the first example says, okay, what if my acceleration doubles? So what if my acceleration is twice as big? It was 3 and now it's 6. What does that have to mean about about the force that is causing this thing to accelerate? Well, if I double A, I rearranged it all and I said, okay, well, doubling A means that my force has to be doubled as well. And so that's kind of how we argue our way through that. So then B is the same question. It says, what happens to, in this same equation, F equals ma, the relationship between force, mass, and acceleration, what happens if all of a sudden my force stays the same, or my acceleration stays the same, Force is what we're analyzing. The acceleration is the same, but my mass has decreased by a third. So you got lighter somehow. I'm pushing Jedediah in a chair and he chops off his legs. What happened? I don't know, somehow very quickly, he chopped off his legs. Okay. Well, what does that do to the force that I'm applying if the acceleration is going to remain constant? So assuming everything else remains unchanged, I want Jedediah to accelerate at the same rate. He's chopped his own legs off. If we're going to maintain the acceleration, what has to happen to the force? Is effectively what the question is being asked here.
You have to push them less.
You have to push them less. How much less? Well, so if mass is decreased by a third, how do we represent that mathematically? What does it mean to be a third less than something? That's 3 times? That's tripling something. You want to be a third less than what you were. Yes. Divide by 3. That would take you down to a third of what you were. We don't want to go down to a third. We want to decrease by a third. The language here is important. Times by 1 over 3. That would take me down to... I'll do it on the board. Just wait. Just give me a sec. Okay, so you said multiply by a third. Someone else said divide by 3. If I had a value, let's pick 9. 9, and I'm going to divide that by 3, or I'm going to multiply 9 by a third. What is that value? What is 9 divided by 3, or 1/3 of 9? 3. Is that what we're looking for here? No. I want to decrease 9 by a third. So what do I want? Well, if the value is 9, what's the value we're looking for? If I take away a third from 6, I want to find 6. So what do we multiply by? You said, Sienna, you want to subtract something? What am I subtracting? How do I do 9 minus a third of 9? Well, if I have 9 minus a third of 9, that's how I would decrease. But there's another way to write that. What's the other way to write that? If I have a whole 3/3, and I take away 1/3, how many thirds do I have left? I have 2/3. So instead of minusing a third, I could just say, well, I'm just going to multiply it instead by 2/3. There's different ways to think about the same mathematical operation. If I want to decrease m by a third, what that means is I'm going to take my m and I'm going to say it's going to be 2/3 of what it was times a. But this piece here hasn't changed. This ma is still how we defined the force to begin with. So what happens to the force if, now you can be more specific, Abdu. I'm pushing Jedediah in the chair, I want the acceleration to remain the same, and he just cut off his legs.
Less.
How much less?
Third.
A third less, or 2/3 of the force I was applying before. So this would be 2/3 of my original force. And this is something, we analyze conceptually things like this in physics all the time. Without having concrete values, what does it mean to change some of our unknowns? Okay. Let's jump down here.
Yeah, can I share how I did it? I guess.
Which one?
The one we did.
Sure.
Yeah. I replaced the values with just numbers. So m would be 3, a would be 3, and f would be 9. So
Yes.
I increased 3 by a third. So I don't know, it's easier to do.
Replacing unknowns with values to help you conceptualize it, totally acceptable. Yeah. If I don't give you values to work with, picking your own is a great way to deal with it. You betcha. But then being able to recognize what the relationship is between the values that you picked is important, because at the end of the day, you still need to answer the question. What happens to f? So your original f value was 9. You decreased it down to the mass, if it was 3, then decreasing it by a third would bring it down to 2. 2 times 3 is 6. How are 6 and 9 related? You would still have to answer the question. The force would be 2/3 of what it was. But yeah, picturing with values, totally acceptable. I'll do another example from down here. We're not going to spend a ton of time doing this, but I do want to show you that it's a thing. Let's look at A here. This is another formula. F is still force. I mentioned G before. G is the universal gravitational constant. You'll learn about it in the next chapter 3. M and M refer to the masses of some objects, and D is the distance between them. So this is the relationship that exists for gravity between objects. What happens in this expression if the distance gets twice as big? Knowing that this is related to gravity, this should help you. You standing on the surface of Earth have a distance between the center of the Earth and you, and gravity acts on you accordingly. If I took you and I chucked you out into space, what is the force of gravity from the Earth on you going to do? It's going to decrease. As you get further away from our planet, eventually it's not going to have a measurable impact on you. So conceptually, we can say, okay, now that I know what this formula is about, it makes sense that it should go down. Well, how much? If I'm going to double the distance, let's use our formula. F equals GMM, I'll call this F1, over, and I'm going to replace D with what expression? How do you double something mathematically? Multiply it by 2. And I want to be careful how I do that. I want to multiply D by 2. So you have to substitute it properly. We're going to throw a set of brackets where D was originally. The squared goes on the outside, and on the inside is where we shove our 2D. And now I can do some simplifying, something that I would have asked you to do in grade 9. Simplify this expression for me. The G stays, the M stays, the M stays. What happens in the denominator? You bring that exponent in, and the denominator is going to become what? 4D squared. This piece right here is what we started with. This is our original force. So now what I've got here is that F1, our new force, is going to be equal to F over 4. So if I double the distance, what does that do to the force? Vikram. It's a quarter of what it was before, you betcha. If you double the distance between the two objects, if I took you are 6,872 kilometers from the center of Earth. If I doubled that distance, I put you the distance from the center of the Earth to where you're standing right now, and I moved you that far away. The force of gravity on you would be a fourth of what you're experiencing right now, is what this means. It will help more when we actually plug values into this, but this is the exercise. We're not going to do a lot of it, but I do want you to be at least familiar with the technique. You don't have to be comfortable with it, but I do want you to see it. Okay, so because of the fire drill, this is where I would have liked to have gotten to yesterday, but we obviously did not. I'm going to give you at least half an hour. We'll see where you're at. I would love to reach trig today, but maybe we don't get to it. Take a look at this page here. I don't have the answers on here. I have my answer key here when you're ready to see it. Don't cram all of your work onto this page. There is not enough space. So either move to the whiteboards, grab yourself some line paper or some blank paper, organize your work, and then when you're done, we can give it a check. I'm going to give you a bunch of time today, maybe the rest of the block. We'll see how you guys do. And I can support you where needed. I want you to try solving formulas for the variable indicated for 1 and 2, and then 3 through 7 actually gets you to do something with the formulas you're isolating. So on your mark, say giver. I'll put on some music and away you go.
efficient, fast, and good to erupts number.